So we are just picking right up where we left yesterday, and we are continuing with graphing linear functions. And we're just going to look at some more specific things that can come up when we're graphing. So first off, let's look at y equals 2/3 x plus 2. So we said yesterday, if we wanted to graph this, we were going to plug in input values of -1, 0, and 1. Now I'm writing this lightly in pencil because we're going to run into a dilemma here. If we plug in -1 and we do 2/3 times -1, we'll get -2/3. And hopefully we at least recognize that -2/3 plus 2 is going to be a fraction. Okay, and I said no fractions when we were graphing these. So if we're plugging in those regular values that I was giving you as a good starting point, things are going to start to get messy really quickly. So the trick is here that if we have a fraction in this, we want to plug in 0 in the middle. So this middle number is always going to be 0. Okay, and we want to do the denominator, which is the bottom of the fraction, and the negative of the denominator. Now, really, truly, any number that is a multiple of the denominator is going to work. So the denominator here is 3. So 3, 6, 9, -9, -6. But again, just that idea that we want to be nice and centrally located on our coordinate plane. If we do 0, the denominator, which is 3, and the negative of the denominator, which would just be -3. Okay, that's going to cause those values to cancel out, and we won't end up with a fraction. So just like yesterday, we're going to plug these values in. So we'll say 2/3 times -3 plus 2. Now, some of you might be more dependent on a calculator because of the fractions. So remember 2 ABC 3, and then a parenthesis, -3 plus 2, right? That's how we can type it in and get an output value. Now, also remember when we're multiplying fractions, right? If we have something like this, these are really canceling out, and we're just getting a -2/1. So -2 plus 2 is 0. 2/3 times 0 plus 2 will give us an output of 2. 2/3 times 3 plus 2. Right, and again, you could do this in a calculator. Will give us an output of 4. Okay, so on our coordinate plane, we then want to think about these as ordered pairs. We're going to start plotting these points. So now we have the point -3, 0. Now make really sure that you're doing these in the correct order. -3, 0 is -3 on the x, 0 on the y. Whereas 0, 2, right, is 0 on the x, 2 on the y. And then 3, 4. Okay, so yesterday we said that these should always create what shape when we graph them? It should always be a line, right? These are linear functions, so we should have a line, which we do. So we're going to make that graph across the grid, and we're going to put arrows on both ends, right? This line is representing all of the points. There are tons of them, but instead of having to actually write them all down in a table, I'm representing it with a graph. Okay, it's all the points x and y that will make this original function rule true. Okay, so our second one here, 4x plus 3y equals 9. Okay, so if we're looking at this one, this is not in our function rule format. So what did we say that we would do yesterday? What did we say we would do to get this in that right format? We want to solve this for y. Okay, so if we have 4x plus 3y equals 9, what are we going to do first to solve this for y? We need to subtract 4x from each side. Okay, so these cancel. So now I have 3y equals a -4x plus 9. Okay, now if I want to finish solving this for y, I'm going to divide by 3. And how many places do I want to divide? Right, all 3, each of these individual terms needs to be divided by y. So I'll get y equals negative 4/3 x plus 3. Okay, so I no longer care about this one over here, and this is what I'm using, right? These two equations are equivalent. They look different, but they represent the same thing. Okay, so we said that we want to use 0, the denominator, and the negative of the denominator. So what values are we going to want to use for this problem? We want to use -3, 0, and 3. Now, if you said, well, what about this negative up here? Does that affect the denominator? Well, I mean, you could think about that as being a denominator of -3, right? These are the same thing. But either way, if we're taking the negative of it, the negative of -3 is +3. And so we end up with the same numbers. It doesn't matter what order we are at in the table. Okay, so let's plug in -3. So if we say -4/3 times -3 plus 3, what output value will we get on this one? Okay, so if you're using a calculator, you should have done -4 ABC3 in parentheses -3 plus 3 equals, which gives us a 7. Okay, then we're going to plug in the 0. The 0 will give us a 3. Then we're going to plug in the 3. So what value do we get out when we plug in the 3? We should get out -1. So now we're going to plot these on our coordinate plane. We'll have -3, +7, 0, 3, 3, -1. Here's our line. We're going across the coordinate plane and arrows on both ends showing that that continues in both directions. Let's say that we are given x equals 4. Now this is a weird example, right? Because there's no y in this problem. So now when we go to pick our x values, we don't have a choice. This tells us exactly what it has to be. X has to be 4, which means when we're doing this, our x values here have to be 4 every single time. X is 4, it can be nothing else. Now, there's no rules about y. Y can be whatever we want it to be. 0, 1, 2, 3, 5, 7, right? Anything we want it to be. So when we graph this, we'll get 4, 0, 4, 1, 4, 2. This is sort of our one exception to the rule. This is linear, but this is not a linear function, right? This doesn't pass that vertical line test. So it's linear, but it's not a function. Okay, and I just tell my students, if you can remember, if you can memorize it, or if you can think about it through every time, an x equals line is always a vertical line. It's opposite of the direction of the axis. So the x-axis is horizontal, and x equals line is vertical. Okay, so let's look down here. Y equals -5. What numbers are we going to have to put in our y column? Yeah, we have to put -5 every single time, right? Just like up above, we had to put x is 4. Here we have to put y is -5. Now, our x values can still be whatever. Okay, but our y value has to be -5. So if an x equals line was vertical, what might we predict is going to happen with our y equals line? Okay, horizontal would be a good guess, so let's see if that happens. So if we have -1, -5, 0, -5, that's looking really promising, right? 1, -5. So our y equals line is always horizontal.